Okay, it's new product time. First up, it's a remote.
This is the OSMC remote. It's not just any remote. It's a remote that is designed to be used with the Raspberry Pi if you turn it into a media center, and it's designed by It's actually designed and sold by OSMC. It's an RF remote, so you don't have to have line of sight. It's just a lovely remote. So if you want to turn your Raspberry Pi into a media center, this remote works automatically with OSMC, and it has a build for Raspberry Pi. So it just makes it like super easy for you to like immediately. You don't have to get a keyboard and like map the keys and figure out like what is the connection. And it's got like lovely up and down and back and play and pause. Like There's like hacks and stuff, but this is kind of nice.
Fun story about this. We did a Twitch broadcast.
Yes, Tony D ran OSMC on Pi 3.
Yeah, and they emailed us and they're like, hey, you should talk to us. We're like, you're right, we should.
And it's actually a good idea because they make an open source, a Linux distribution for Raspberry Pi. And so because of that, it's open source. They don't make any money by distributing it. And so they maybe have some ads on their website, or maybe that's for donations. But it's really smart for them to say like, well, here we can make a hardware accessory that if you download the software for free, here's something you can purchase to help support the effort.
Yeah.
Smart. All right, so pick one up if you would like to support them.
That's right. Okay, next up. This is cool. This is from Thames Kosmos. It's a wind power. It's big.
Okay, and this is bigger than you think.
Yeah, it's bigger than you think. I want to show a couple quick videos. You can hear the whirling.
Hard not to wobble it. You get it on for like good 3
and
seconds.
this is just some stuff that we shot here
Yeah, go for it again.
at Adafruit.
Yeah.
And it's pretty.
I think it's just someone spinning it with their hand.
Yeah, we are, and this is just to show you
All right.
that it is a fan that moves, and it's wind power, and it means that when air hits it and spins it, you can get power from it.
That's correct. You can get electricity from it.
You can get electricity from it.
And I can show this off. It's big, so you have to go. Sorry, no, don't worry.
Okay.
Okay, so this is it. This is why I actually like it. It's not like a little mini kit. So like we have people who email us and say, okay, well I want to learn how to like do like wind power, and Earth Day's coming up in a couple days. And so we have a couple solar projects. We didn't have any wind power. So this is actually really nicely made. It's actually basically a motor, right? It's a geared motor. You've got these really good light blades, but they're strong, connected to a shaft. And then there's a gearbox. There's another gearbox. There's a motor. And then on the back there is a battery slot, so you can put. It's not super high current, so I think you put NiCad or nickel metal hydride rechargeable AA in here, and it will recharge the battery.
That's cool.
Or you can flip it to in or out. If it's out, it'll go the other way. The battery will
power that,
drive the motor, and it'll turn into a fan. So it's a good way of learning. Like, hey, an LED is the opposite of a photocell. They're the same thing. Just a photocell is really big, and it's tuned for sunlight. And a fan and a wind generator is also the same. And so you can tune, you can tweak and tune the the fan blade. No, this is like pretty intense. Like you can adjust it for best performance. You're not probably going to get more than a couple milliwatts out of it, but this is way better than the little mini desktop. So you could put this on your roof or in your backyard, and you could mount it if necessary to a large pole to learn about wind power. So I think this is kind of neat. This is a nice kit. Most kits are much smaller, and so you can barely do anything. But this is
cool.
a nice big kit.
Okay,
so thank you.
Yeah.
And this is a suggestion from the new products team too.
All right. Yeah, thank you, Alon. Next up, there's a couple stars of the show besides you tonight. This is a series of things. We're into this.
Yeah, there's 4 items, and they all sound very similar. So I'll explain them. We have packet radio breakouts. These are data radios. These are not for streaming audio or video. I mean, you can maybe stream little pictures and like very, very low grade audio if you wanted to have super low audio, but this isn't like an FM or AM radio, and it isn't even as fast as Wi-Fi. This is about like 9600 baud, 19.2 kilobaud radios that are meant for transferring data back and forth. Now, we already have radios in the store. We have Bluetooth and Wi-Fi, and those are really great when your Arduino microcontroller is talking to a tablet, iOS, Android, desktop Mac, desktop Windows. But there's trade-offs. For one, Bluetooth Low Energy, like it's not good for talking from one Arduino to the other. And also you can't do multi-point data. Wi-Fi, you can have all of them on a network, but it's a really high power thing and you have to maintain this connection. Like you have to pair to the SSID and then you can transfer data and then disconnect, and it takes up a lot of power. So what these radios are really good for is they can go much, much farther than Bluetooth or Wi-Fi. These can go about a mile or a couple miles each, line of sight, and then divide by 5 or so if you're bouncing around some buildings. They don't use nearly as much power. You don't have to pair, and the protocol is very simple. Like you basically power up the radio, send some data, listen to some data, and turn it off. You can make your own mesh networks. You can make multi-point networks. You can make point-to-point networks. Some of these have encryption built into them as well if you want to do that. Some have subnet addressing. So these are much better for network nodes where you have in a city or a town or even a building, you want to transmit data around without having to have the overhead of Wi-Fi, and you don't want to do the point-to-point only, the one-to-one only of Bluetooth. They're actually a little bit like XBs, but they're a little less expensive because you're not kind of paying for the whole XB name. They're much simpler. So we have two families. We have the RFM 69.
Okay.
And that is a packet radio, and I'll show off the demo with it. This is the RFM 69, and we have it in two frequencies. 900 megahertz, best for ITU2 Americas.
Show the other one? Should I show the other one?
No, not yet.
Okay.
This one's great. We have it in 433 for Europe, and 900 megahertz for America. Pick the one for your zone. You can actually use 900 megahertz. You tune it to 868 in Europe. You can also do that. And if you're amateur radio and you have your call sign, which I don't have yet, you can use 433 in America with restriction. So here is the Feather version. So this is an all-in-one microcontroller board that has that radio on it and also has a microcontroller. And I just have it battery powered. And this is my little helper. And I just attached a little wire antenna. So what this is going to do is...
I thought I was your little helper.
Okay, this is my little OLED helper. What's wrong with you? And when it gets a packet, it's going to print it out. So this has been streaming packets all along. So it gets packets, it says hello world. Okay, so if we remember that over there, and then we're going to introduce this other helper. So this is an Arduino compatible, and it has that breakout. And what this is doing is it's transmitting data to here, and whenever it transmits and it gets a response, an acknowledgement, it blinks the LED. So it knows. So, 16, 17, 18, and this is a simple demo. All it is sending hello world with a number incrementing, so you know it's working. And this is right next to each other, but of course this could be about a mile apart. So just imagine my desk is a mile long, and it is happily transmitting data back and forth. These radios are pretty easy to use. There's some awesome libraries that exist for them. SPI works with, so far I've tried a couple different chips and it works fabulously. You can use either the Low Power Labs, RFM 69 library, or you can use Airspace's Radiohead library, which you can also listen to while listening to OK Computer. And these radios, unlike the Feather, you can use more than just a wire. For example, here I have it connected to a large 900 megahertz dipole, and I'm using a UFL. This is a UFL connector, so you can solder a UFL connector, and it stopped blinking because it's no longer sending packets at a strong enough. It's receiving them, but this won't reply unless the strength is higher than a certain amount. So you can use a UFL and attach it for a box or something. And UFLs are small and easy to connect, so that's good. You can also use, let me get my demo, 1 second. You can also solder in an SMA connector. So if you want to connect your antenna directly, you can get an edge mount SMA. I really love these connectors. You solder it on, you solder it in, and then you can just attach it directly to an antenna. This is mechanically much stronger than the UFL.
It's fun because you can go like that. That's the
You
fun part.
can do this all day
That makes a sound.
if you want. Decide horizontal, vertical, whatever. long, bent, so you can attach an external antenna that way, or you can go simple and then have just your simple wire antenna. If you don't need the distance, perhaps, or if you want to just not spend extra money, that's fine. Just attach a piece of wire, and this is good for most uses as well. So that's the RFM69 HCW. So this one is good for about 500 meters up to 500 meters with just wires and point to point. And I think if you have some directional antennas and you tweak the settings, you can maybe a little bit slower on the bit rate. You could probably, I think you can go like a mile or so, maybe a mile or two. I don't remember the exact number, maybe 1.2 miles or something. When you're doing point to point, of course, you'd want to get your directional antenna for that if you know how far you want to get to it, or maybe the transmitter has a dipole and then you have a directional on the receiver. Okay, so you're thinking, that's really great that you can go 500 meters or maybe a mile or something. But let's say I want to go even further. I want to go maybe a couple of kilometers, or maybe a couple miles. You can do that with LoRa radios. So LoRa radios are also digital radios. Can you go to 72? Yes. Okay. So the RFM9X LoRa radio. You might be thinking these look identical, and you're right. They look very, very similar. But
that's what I was thinking.
Yeah, they look really, really similar. But the LoRa radios have a patented modulation scheme, a spread spectrum scheme that allows it to work over very, very long distances for the same amount of power. So for that same 20 dBm output, instead of going 500 meters, you can easily go 1.5 kilometers, 2 kilometers. We found 4 to 5 times farther than normal packet radio with this modulation. Again, look at the product pages for the exact. We did some measurements, and we're doing more measurements all the time with different antennas and such to get you good ideas. But someone did say they did a LoRa radio and they got 20 kilometers out from these radios. Using directional antennas, so
that patent really does work.
No, Semtech, which makes the chips, they bought a company that I was reading about it. They bought the company that came up with it. It was a French company, and they got it for $5 million. And I was thinking, wow, that's a bargain.
Okay. Is there any other ones you want me to show? Because the thumbnails look kind of similar.
They all look similar. I think this last one is the 433 megahertz version. Yeah, it has a red dot, but they are different protocols. There's very similar pins because it's actually 2 different chips from the same company. One is the lower cost packet and one is the LoRa packet. So, the LoRa one, you can also apparently do FSK or OK, with it. But honestly, I wouldn't pay for LoRa and then use it with this non-LoRa modulation. I would get the simpler RFM69 packet radios for that. But we have these larger ones. Just remember, they can't talk to each other. So if you have an RFM69, you can't talk to a LoRa with it. You have to. The LoRa modulation only works between 2 LoRa modules of the same frequency. So just keep that in mind. But you can have a whole bunch of devices on the same modulation and frequency band if you want. So if you have a greenhouse and you want to have multiple sensors, or you have a home and you want to have multiple sensors, or a building or a town, and you want to take weather data from different locations and collect it, this can be really good. And of course, these radios can go into very, very low power modes, much lower, and then come up instantly. Unlike Wi-Fi, where you have to come up and associate and pair and then get DHCP and get your, this is you bring it up and you send a packet and you're down again all within 10 milliseconds.
What a great time to be a hobbyist. I wish I could send this video, or maybe I already did, because I was thinking the maker movement was going to be fun. This video back in time, 10 years ago, this is all low cost, low power, very easy to use. Mm-hmm. It's amazing.
Yep.
That's so cool. Okay, well, good work, Lydia.
Okay.
That was the new products fix.
It's time to play with radio.